So today I want to add a cool explosion effect to my pumpkin panels code. Run the code and show what I'm talking about. So I've got my pumpkins here in a different color. I can do cool things like bounce. I can add multiple pumpkins to each panel. I can have them spin around and change how fast they spin. I can reset them. But I thought it would be cool if I had an effect where I could explode the pumpkins. So that's what I'm going to do today. So here's the code I'm working on. I'm doing this in Python. I know I've done a few Java tutorials in the past, so I figured why not just do Python this time. Here's the main code, and here's the pumpkin class, which has all the drawing of the pumpkin, spinning, and stuff like that. So in order to do the explosion effect, I have to kind of visualize what the explosion is going to look like. So I could do sort of like an explosion with fire and stuff, but I really don't want to do that. I don't think it'll look as good. It won't really fit the theme of the cute pumpkins. So I'm thinking maybe something like a firework explosion. And looking at these different photos, I can kind of visualize what the explosion is going to look like. If you look carefully at the picture, it looks like there are a bunch of lines that are kind of sourced from the center, some center area. And they're kind of spread out and they move outwards from the center and then slowly fall down. Fall down like going towards the bottom of the picture. That's going to give me kind of a guideline of how to go about making the explosion. So instead of trying to integrate it into my code directly, I think it's easiest if I just start a new sketch and figure out how to do the explosion on its own, like in a simple case with just a simple sketch and no other code I have to interact with. So let me set up the draw and setup functions. Whoops. Pass here for now. And I saw from the picture over here that it has multiple lines that emanate from the center. That's kind of telling me that maybe I need a list of all the, let's just call them particles. My particles list. And then I'm thinking in the list, there's going to be a particle object. So let's say object, that's going to mean class. Class particle. I'll make my constructor. And what do I need to know about the particles? Going back to the picture here. I know they all kind of start from the center and they all go outwards. So what that means is it's going to have a starting spot, like an origin. I'll call this X and Y. And I'll have two instance variables or member variables for those. So hold on to them. It's passed now. And once I have that, I need to know how to move each one of the points through this particular space. So outwards and then falling down. To do that, I need to figure out how to draw that. I'll make a draw method. And what this is going to do, it's going to draw a line that's going to represent each particle of the firework explosion. So this is going to be pretty easy. So the processing has a line function. It's just going to be x1, y1, x2, y2. Let's start off with just black. So if you remember, fill is used to fill in the colors for shapes. But if we're doing a line, it's just going to be stroke. Stroke is the outline. So it's just one line. It has no fill. You only use stroke. And 0 is black. You put in one number, 0 is black. 255 is white. Because one number means grayscale. It means white, black, and everything in between, which is gray. Stroke, weight. This is how thick the line is going to be. Let's just say it's 5. Right. So for the line, it's going to have an x1, x2, y1, y2. So I have my x and y, but I need my x2 and y2. So let's just make 2 other x and y variables. Let's call this one old x. Then y. Let's say in the beginning they're both equal to the same number. We'll move them later on because there's going to be a velocity for the line that we're going to keep track of. All right. So let's see if we can visualize how the firework's going to work. And we have our center point for our particle. And what we want it to do is travel outwards at a certain angle, and then slowly start to come down. And we're going to have a lot of these kind of particles on these different trajectories, but this is just one to visualize. And what I can think of this as is just lines that are connecting, and each line here represents one frame as the explosion gets drawn. So the first frame is going to be this dot over here that connects to this one. The next frame is this one and this one. And then we have hundreds of these little particles that take different trajectories. Maybe one goes to the left, one goes more upwards, one goes more down. But it's going to be an explosion from the center, and they're going to have different trajectories. And how do I figure out where the location is of each dot as it progresses? Well, I need to know where the second dot is going to be. And that's just going to be a random location from the center. So I said this is the center over here. Then it can take in different locations from the center, meaning it can go this way, this way, this way. It almost looks like a sun. So that means I need a random angle to say where the particle is going to go out from the center. To do that, I can just say 224. To do that, I can just say I need a random number from 0 to 2 times pi. So 0 would be, facing the right. 2 pi would go all the way around in a circle like that. And that would give me a random direction of a particle from the center. I also need how far to move it. So some other particles are going to move, say, smaller points. Some are going to move longer. What I need is a random magnitude, for lack of a better word. So I have a random magnitude. And this is I'm just going to pick numbers. Let's say it's got to be greater than 0, but not really, really large. Right? This has to kind of have an effect of not being just one long straight line. Because if it's one long line, it's going to look straight and not going to update its position on these points quickly enough. Let's just say it's going to be, let's say 3 to 10. These are just random values between these ranges. Go back to my code and let's figure out what these values are. Do I need to make them instance variables? I don't think so. Call it my direction. And 0 to 2 times pi. And then my magnitude is going to be, what did I say, 3 to 9. I say 9, 3 to 10. There you go. I think this is all caps. Yeah, 2 times pi. Now that we have our random magnitude and random angle from the center, we have to do is figure out how to draw the two ends of the points. So this is our center right here. What we want to get is where these points are. And these are going to be the ones that connect each frame to form a particle. So how do we get x2 and y2? So if you remember the center in the beginning, it says x1, y1. And this point over here is going to be, oops, it's going to be x2, y2 here. This point. Maybe I should make that point a little bit bigger. Yeah, there we go. That looks better. So how do I get x2 and y2 from x1 and y1? Well, I need to figure out how much the x position changes, how much the y position changes. And when I made that drawing, you can kind of see it forms a right triangle. Let me make it a little bit nicer though. A bit nicer. Maybe it's not the most accurate picture, but imagine these are straight lines and forms a right triangle. And with the right triangle here, you can use trigonometry to figure out how much the x component is going to change and the y component. We need to figure out how much these are going to change by from the center here. How much does it change for the x, and how much does it change for the y? Well, if you remember our trigonometry, cosine times the direction or the angle, I think I called it direction, is going to be the x component. And then our y component is going to be the sine of the SOHCAHTOA. And sine and cosine only give us numbers between 0 and, or -1 to 1. What we have to do is times that by our magnitude. All right, so this gives us the x box of x component. And this gives us our y. So these are how much it's going to change from x1 to x2, this value, this equation here. How much y2 changes from x or y1. It'll be the magnitude times the sine direction. Our angle is going to be our angle that's over here. This is the angle right here. Let's go back into the code. Okay, that's it for the math. That's it for the math there. So let's go back and put that into the code. Say, I'll need to have an x velocity because I'm going to apply that each time. I need another variable. Velocity equals, maybe I should say velocity x. Keep in line with my old underscore x, not velocity x equals mag times cosine. Okay. That's good. Then I'll also need a size. Let's just say there's a size up here. Oops. Equals 10. So I need to give it a size. Instead of 5, I'll just say it's better to have that as a variable, I think. All right, so now let's start making the variables. Go over setup, make my sketch 800, 600, random values. You can pick any values you want. And let's make my first particle. Y in range, let's make 10 particles. Say, particle equals, and what are my inputs for the constructor, x and y? Let's just do the center of our sketch. Then I can say append, add to my list, new particle. Right, and then for the draw, put a background, give it a white background, 255. 255 is grayscale, where 0 is black, 255 is white. White background. And all I gotta do here is particle. And then I'll do dot draw. And see now that I'm missing one thing. So if I do draw, it's going to draw the same values each time because I don't have a way to update x1 and y. x1, x2, and y2. What I need now is a update method. How am I going to update it? I need to say dot. I need to save the current x into the old x. Dot old x equals old y equals dot y. And now I need to update x and y, which are the new points. So x and y are going to be the newer points, the x2 and y2. And old x and old y are going to be x1 and y1, the one closest to the center, the starting point. Self.x equals, or plus equals, I should say, plus self dot velocity x. I'm going to add the velocity of the x and y component to my new coordinates here. Then I need to change this to x, y. Okay. Let's see how that looks. Actually, this may draw too quickly. Let me tie this to a key press. So I'll say if say A. So when I press A, it should draw the particles and then also update. Update afterwards. Doesn't matter. All right, so let's run this. See if there's no errors. And A. All right, you saw that? We got a bunch of particles coming out. Random directions, random speeds. Again. That looks good. Let's add some more particles. This is easy. We just change the number inside of our loop. Instead of making 10, we make 1,000. Let's do 100. Let's do 100. 1,000 next. That looks pretty good. Getting closer and closer to that firework feel. All right, and we can change a few things from this already. We can change the magnitude. If we want the lines to be longer, let's times these all by 10. See what it looks like. They'll move out a lot faster and the lines are more straight. More straight, no, they're just longer lines. You just can't really see it though, because it's too fast. But yeah, you can change the magnitude there if you want. I like 3 and 10. Looks okay. And you might have noticed one thing is that when we run this, particles, they all kind of move out and then don't fall down as if there's no gravity. I could do it this way, kind of simulate like a explosion in space or something, but let's add a gravity component. Make a new variable for gravity and let's say it's equal to 1. Then what I need to do is add it to the y value in my update. So we don't want to just say plus self.gravity because this will just make the entire value here just a number that's the same each time. Gravity is an acceleration. So what we have to do is find a way to increase y velocity or velocity y more each time it runs update. That means we have to do self.velocity y plus equals .gravity. Right, this means that this amount that gets added to the y value is more each time. So let's say it's 2, and the next time it's going to be add 4, and it's going to add 6, 8, whatever. It's not going to be the same amount. Now, see if 1 is too much. It's a little bit too much. It just kind of all fell down. Too much gravity. Whoops, 0.5. Do that. 0.5 is okay. Do 5, half that. I think that looks pretty good. That looks pretty good. So I added the particle class. I gave it a little bit of extra parameters you can customize it with, like the minimum, maximum size, the particle color. So it's not always just black and white. But pretty much using the same code. See the magnitude times the cosine and sine for the x and y velocity. And then the width, I changed that. I have it different colors, and this is the same too. So let's see how it looks. Add a few pumpkins here. And boom, explosion. Nice. Add more. Looks good. Let's see if I can spin it. Let me spin it. Load it. That looks good. And that's it for the exploding pumpkins. And you can do this for any type of object. They can all explode. If you want a fireworks type explosion.